So we'll wait for another 5 minutes before we start. Good evening. Welcome to the week 5 live session of the course Basic Environmental Engineering and Pollution Abatement. I'm Niketa. I'm a PhD student from IIT Madras, and today we'll be covering some selected topics from the week's lecture videos, and then we will be solving some MCQ problems. Is my audio clear? Am I audible?
Am I audible?
Yes, ma'am.
Okay, so good evening and welcome to this week's live session on the course Basic Environmental Engineering and Pollution Abatement. I'm Niketa, I'm a PhD student from IIT Madras, and we will be seeing a brief of some selected topics from the lecture videos of week 5 lectures, and then we will be solving some MCQ problems. Okay, so air pollution removal. Now, before we begin with air pollution removal, we need to see what are the different kinds of air pollutants. So, can you give me some like categories of different air pollutants?
Primary and secondary air pollutants.
Primary and secondary, yeah, but in terms of their nature, in terms of their character. So, this can be classified into gaseous, particulates, and a mixture of both gaseous and particulates. So, for removing particulates, we have different equipments. So, before that, can you tell me what are particulate pollutants?
Ma'am, their existence prolonged for a long time. Is it like that, ma'am?
Not really. It's like particulate means some solid particles which are just present in the air. So, there are two kinds of particulate matter which is present. One is PM10 and the other one is PM2.5. Now, what this 10 and 2.5 mean are PM10 means that the particulates are less than 10 micrometer in size, and PM 2.5 means the particles which are, less than 2.5 micrometer in size. So, particulates are nothing but solid particles like maybe fly ash and any such pollutant which are present in the air, and they are also pollutant because PM10 and especially PM2.5 can get inside the lungs and it can stay there. So it can cause a variety of health issues like asthma, bronchitis, etc. So that is why we need to remove these particulate pollutants also. So how do we remove particulate pollutants? Now, when we have particulate pollutants, they are basically solid in gas, right? So since they are two different medium, solids and gases are two different medium, and that's why it becomes a little easier to remove when compared to gas and gas. So in order to remove, there are different mechanisms. So we can have gravity settlers, electrostatic precipitators, fabric filters, cyclone separators, and for removing gaseous pollutants, we will have methods like wet absorption, and dry adsorption. Note that this is absorption and this is adsorption. Can you tell me what is the difference between the two processes, adsorption and absorption? What is the difference between absorption and adsorption? Okay, so absorption takes place in the bulk, plus maybe a little on the surface. Like how you have a sponge and you just put it in a bucket of water, the sponge will absorb all the water. So the water will be present inside the sponge, inside the bulk of the sponge. Whereas adsorption is a surface phenomenon. Now, an example for this can be activated carbon. So, activated carbon is generally used in maybe in household water filters and all. So, this is used for absorbing the volatile organic compounds, and usually the compounds will get adsorbed to the surface of the carbon and it won't go to the bulk. So this is the difference between adsorption and absorption. So for removing gaseous pollutants, we will go for wet absorption and dry adsorption. Okay. So coming to the mechanisms for removing particulate matter. So the first one is gravity settlers. So, what do you think is a gravity settler? Like, what force is used for separating particulates from gases in this gravity settler? Any guesses? Your answers may not, I mean, need not be right always. You can even give wrong answers. It's okay. Everyone is just learning. So, it's a very simple question. So, what is a phenomenon or what is the force that is being used to separate particulate matter and gravity settlers? Okay, so basically, a gravity settler will look like this. So you have the inlet chamber, and then you have a settling chamber like this. So this is the settling chamber. And this is the inlet where the gas comes. And this is the outlet. And at the bottom we have some collectors which will collect the particulate matter. So what happens here is the gas that's coming in, it will have some particulates. So these particulates, they travel in this direction, and because of their weight and because of the force of gravity, they tend to move downwards. Okay. So the velocity with which they move down is called the settling velocity or terminal velocity and denoted as Vt. And there is also the horizontal velocity with which they are coming in, and that is called V. Okay. So what happens is, generally there is when there are velocities acting in two directions, there is also a term, something called a resultant velocity, which will act in this direction. This is resultant velocity, so it's called VR. And what happens is, generally based on the weight of the particle, suppose the particle is here, it will tend to fall down. And when it tends to fall down, it is collected using these collectors here. So once all the particles have come down, it will be collected and it will be disposed.
This entire
thing will be separated and it will be disposed. So this kind of device is used for particles which are greater than 50 micron in size. Why can't we use this for less than 50 microns? Any guesses? Why can't we use this process for small size particles? Okay, coming to the first question that I asked you. So the question was, what is the basic principle behind this gravity settlers? So this is based on the force of gravity. So when you have a particle coming in, because of the weight of the particle, it will tend to move down. Okay, but it also has some velocity which keeps making it move forwards. Now you have two kinds of forces, one which is acting downwards and the other one which is acting horizontal. So what happens is, there is a third kind of velocity which is resultant velocity, which will act between these two, and then it will make the particle move downwards and forwards. So based on the weight of the particle, if the particle is heavier, it will, as soon as it comes in, it will come down, it will fall down. But if the particle is slightly lightweight, then it will travel for some distance. It will travel for some distance and then it will come down. So depending on the particle size, the place where it settles also will change. Now we'll learn more about this when we discuss about sedimentation tank design, so which is coming up in the next few weeks. So this is actually based on gravity. So now, can you answer this question, like why can't we use this process for lightweight particles which are less than 50 microns in size?
Like it won't settle.
Yeah. So when you have very light particles, they generally don't settle and they tend to get carried away along with the outlet gas. Okay, so now we saw what is the settling velocity or the terminal velocity. This is denoted as Vt, and this, when you have velocity, can you tell me the general formula of velocity?
What is velocity?
What is velocity? You have some numerator and you have a denominator. Velocity is what? Velocity is distance.
Distance traveled by
Yeah.
time.
Yeah. So in this case, when you have a terminal velocity which is in this direction, um, so can you tell me what will be the? I mean, you can say that this is the height of the chamber. Let's say the height of the chamber is denoted as h. And if you have a particle which is coming in and you want to find out the Vt of the particle, then the distance traveled is going to be the height of the chamber h. Now that is going to be divided by time t. Now the time t here is called the settling time. Can you tell me why it's called the settling time? When you have a settling velocity and you know the height of the chamber, then settling time is the time that a particle will take, and the particle is traveling at this velocity. So it should take time t to travel through the distance h to reach the bottom of the chamber. So the settling time is nothing but the time required for the particle to settle down. Now using a balance of forces, we can arrive at the formula for settling velocity. So settling velocity is nothing but square root of 4g into dp into rho p minus rho g divided by 3 into cd into rho g. Now cd is nothing but 24 by re. So re here is Reynolds number. So substituting this, Vt will become equal to square root of g into sorry, there's a square here. Now, how do we get mu g here? Can someone tell me? So this term has become this. Can you tell me how? So viscosity equals density divided by Reynolds number. So using that relation, we have substituted here and we have got this formula. So this is the final formula for settling velocity. Okay. Now we have another type of settling chamber, which is a Howard settling chamber. So can you tell me how this works? What is a Howard settling chamber and how does it work?
No idea, ma'am.
Okay. So previously we saw how gravity settlers work. So gas laden with particles come in and they settle down, and then the clean gas will move out. Here the design is slightly different. So there are some plates in between. So when gas comes in, it will come through this, and then it'll I mean, so it'll pass through the plates. And some particles will settle here also, and then the clean gas will come out. So what happens here is when we have particles along with the gas, they don't have to travel the entire length of the entire height of the chamber. Instead, the height will be slightly reduced. So since there are plates in between, the particles need not travel the entire height of the chamber. Instead, they just have to travel for a short distance, which is del h. So the interval between the plates is del h. So particles which are more heavier will settle at the top, and particles that are heavier will come to the bottom, and those which are slightly finer will settle at the top, so that they don't have to travel the entire distance. So in terms of efficiency, this Howard chamber can capture, it has a slightly better efficiency when compared to the gravity settlers. That's because the height is reduced. So lighter particles, they generally don't have much weight, and they won't travel for the long distance. So they can be collected at the first or the second plate itself. Whereas the heavier particles, which have a bigger particle size, they can travel the entire distance and they can settle at the bottom. So from each of the plates, the clean gas will come out, and that can be released. So this will ensure that even light particles get separated. Unlike in gravity settlers, where light particles they won't settle down and they will directly come out of the chamber. Here, the light particles are also collected, and they can be separated easily. Okay. So the next method that we'll be looking at is electrostatic precipitators. So what is an electrostatic precipitator? How does it work? How does an electrostatic precipitator work? Okay, so the principle is quite simple. You have two plates. So both are connected to a power source. One of the plates is positively charged,
and the other one is
and the other one is negatively charged.
So
So when you have particles, okay,
suppose you pass particles like this.
like this.
So
So when they pass through these plates, generally particles will be negatively charged, so they get attracted to the cathode, which is positively charged. So here, if you have particles which are negatively charged, they will tend to accumulate on the cathode. Okay.
So then when you turn off
So
the
then when
power,
you turn off the power,
that
the
are attached to
particles
the
that are
cathode
attached to the
will fall
cathode
down.
will fall down.
So
So they can be easily collected.
So
So that is the principle. So you have two different configurations of this. So one is the parallel plate type. I'm sorry. So one of them is the parallel plate type, which is which is very similar to this. You have two parallel plates, and the DC power source. It is connected to an electric power source, and the one of the plates becomes the cathode, the other one becomes the anode. And based on the charge of the particles, it will get attracted to the oppositely charged plate. And the other one is the wire and pipe type. So in this wire and pipe, there is a pipe like this, and in between this you have a wire. So both the wire and the pipe are connected to an external source. So the pipe is generally positively charged, whereas the wire is negatively charged. And when you have particles, air particles will, the gas will be made to enter the pipe from the top. And if there are any particles, they will get attracted towards the pipe. And if there are any particles, they will get attracted towards the positively charged pipe, and they'll just stick to the surface of the pipe like this. And once the current is off, the particles will come and settle, and they can be collected here. So this is the principle behind this. Okay, we've seen electrostatic precipitators and gravity settlers. Now coming to the third type, which is the fabric filter. So can you tell me what is filtration? What is meant by filtration? Filtering, filtration. What do we mean by filter?
Ma'am, like the residues and heavy particles will settle up and the pure form will settle down.
Yeah, that's somewhat accurate. So filtration is based on filtration is based on particle size. So, 1 second. So in a filter, what happens is when you have a filter like this, it will have some pore size. So it will have some pores, and based on this pore size, if your particle is going to be larger than this pore size, then it is going to be retained on the pore itself. But if it is smaller in size, it tends to escape. So this is a filter. Okay. So when it comes to air particles, since particulate matter is just a suspension of solids in air, solids and gases, we can have a filter to separate the gas particles in air also. So this is done using the help of a fabric filter. So a fabric filter will have it's something like this. So here at the top you will have the gas inlet. And I'm sorry, this is the gas outlet. So the inlet is usually at the bottom.
So the gas will come
from the bottom like this,
and
it will be made to flow through pipes like this. Now these pipes here, so this pipe is generally covered by a fabric. Okay, so this fabric here is usually a material like cotton, or it can be nylon.
Or it can be PTFE.
Or it can be PTFE. Can be anything. So usually what happens is the particle that is traveling so the particles which are coming like this, so they will be forced to go to the top, and then we will apply a vacuum force so that it will also come out. So what happens when particles which are whose size is greater than the size of the cotton pores, those will get retained on the surface. And those which are lightweight will come out of the outlet. So after a point, your filter pores will get clogged completely because it is being occupied by all the big
So when that happens, the
size
filter
particles.
efficiency will come
So
down.
when that happens, the
And you
filter
have to
efficiency
do
will
a
come down,
cleaning.
and you may have to do a cleaning. So when we do cleaning, we'll use some kind of a shaker or an oscillator to remove the dust particles which are settled on the pores of the fabric filter. So the principle is quite simple. The gases will be pushed in and it will be sucked out. So when a negative pressure or a vacuum is applied, the bigger size particles will be retained on the filter itself, on the pores of the filter, and the small size particles will escape out. And after a point, when the pores are completely filled, you may need to clean the filter also. So this bag filter is used for removing particles in the range of more than 0.01 to 1 micrometer in size. But there are some drawbacks of using this. One of them is that bag hose filters are large and expensive. So sometimes they are also called bag house filters. Because they are very big units, and sometimes they are as big as a house, so that's why it's called a bag house filter. And it cannot be used in a moist environment.
So
during monsoons and rainy seasons, it cannot be used. And
advantages
advantages
of
of this:
pressure
the
drop is
pressure
low,
drop is low,
and
and
efficiency is high.
efficiency is high. Okay.
So the
So
mechanism
the
by which
mechanism by which
particles
the
get trapped
particles
in a
get
bag
trapped in a
filter
bag filter
can be either
can
through
be
inertial
either
impaction.
through inertial impaction.
So what is
So
inertial
what is
impaction?
inertial impaction?
Imagine this is some surface
Okay, imagine this is
on which
some
you want to
surface
get your particles
on
trapped.
which you want to get your particles trapped.
Uh,
Um,
you
you
have
have
some
some
gas
gas
which
which
is
is
flowing
flowing through this
in
in this
this direction,
direction,
and the gas
and the
has
gas
some
has some
particles.
particles.
So
So
the lightweight
the lightweight
particles are
particles
moving in
are
this
moving in
direction,
this direction,
and they come
and
near
they
the
come near
object
the
and
object
sensing,
and
and
sensing,
they have some
and
velocity.
they have some velocity.
So when
So
they come
when
near,
they come
they
near,
tend to
they
move up.
tend to move up.
Sorry.
Sorry.
So the lightweight
So the
particles
lightweight
can easily
particles can
bypass
easily
the
bypass
object,
the
and
object,
they can go
and
up.
they can go
They
up.
can easily
They can
shift their
easily shift
direction
their direction
because they are light
because
in
they are
weight.
light in weight.
Whereas when you
Whereas
have a
when you
heavy
have a
particle,
heavy particle,
and because of
and
inertial
because of
force,
inertial
it
force,
cannot
it
change its
cannot
direction
change
so
its
easily.
direction so easily.
Imagine you have
Imagine
a
you have a
big size
big
particle
size
here.
particle here.
This big size particle
Now this big size
cannot
particle
easily
cannot
change their
easily change their
directions, and
directions, and
even though they
even
try,
though they
it
try,
can only
it can
be
only
because of inertial force,
be
it cannot
because of
completely
inertial
change their
force, it
direction,
cannot completely change
and
their
because of
direction,
that, they tend
and
to
because
get
of that,
stuck
they
on the
tend to get stuck on the
surface.
surface.
Whereas the lightweight
Whereas the
particle
lightweight
will
particle will
tend to
tend to
move up,
move up,
and it will
and it will
change its
change
direction
its
because
direction because
the flow
the
direction
flow
is
direction is
changing.
changing.
So since
So since
the air
the
is
air
moving
is
over
moving
the
over the
since the air
since the
direction is
air
something like
direction is
this,
something like this,
so it tends
so
to
it
move
tends to
over the
move over
surface
the
and go.
surface and go.
But since
But
we have
since
heavy
we have
particles
heavy
in the air,
particles in the air,
they cannot
they cannot
really travel
really
on
travel
the
on
along
the
the air, and
along the
because
air,
of
and
inertial
because
forces
of
acting
inertial
on them,
forces acting on them,
they cannot change the
they cannot
direction of
change
their
the direction
movement
of their movement
quickly, and that's why
quickly,
they
and
get
that's why
stuck
they
on the
get stuck
surface of
on
the
the
particle.
surface of the particle.
So this is
So this
inertial
is
impaction.
inertial impaction.
And the second
And the
one is
second one is
interception.
interception.
Now, in
Now, in
interception, what
interception,
happens
what happens
is
is
you
you
have a
have a
particle
particle
and
and
it
it
gets
gets
directly
directly
hit
hit
on the
on the
surface.
surface.
And there is no intervention or there is
And
no
there is no
direction change or
intervention or
anything.
there
It's
is no
simple.
direction change or
Like you have
anything.
a
It's
particle which
simple.
is
Like you have a
coming,
particle
which is traveling,
coming,
and
which is
there is a
traveling,
surface
and
on the
there is a
way of the
surface
particle,
on the way
and
of
it
the
just
particle,
tends to
and
get
it
hit on
just
it.
tends to get
So
hit on it.
interception is
So interception is
the effect of interception is
like the effect
somewhat
of
minimal
interception
when
is
you compare
somewhat
it to
minimal when you
inertial
compare it to
impaction and
inertial
diffusion,
impaction and diffusion,
because when
because
you have something
when you
like a
have
pore,
something like a pore,
maybe you have
maybe
a
you have a
cotton
cotton
fabric which
fabric
is
which
like
is like
this,
this,
and these
and
are the
these are the
pores.
pores.
There are
There are
very
very
less
less
chances
chances
that
that a
a
particle
particle
will
will
come
come
and
and
it
it
will
will hit the
hit the
uh,
uh,
place
place
where
where
there is
there
the
is a
fabric.
fabric. So most
Most
of
of
the
the
particles
particles
will
will
just
just
tend
tend to
to travel
travel
to the
to the
pores,
pores,
and
and
it will
it will
just
just
go
go
through.
through.
So
So
the
the
chances
chances
of
of
a
a
particle
particle
hitting
hitting
the
the
fabric
fabric
of
of
the
the filter is
filter
low.
is low.
So that is
So
why
that is why
interception
interception
is
is
the
the
effect of
effect of
interception
interception
is
is
less
less
when
when
compared
compared
to
to
inertial
inertial
impaction
impaction
and
and
diffusion.
diffusion.
Third one
Third
is
one is
diffusion.
diffusion.
So here
So here
it's like
it's like
a
a
random
random
motion.
motion. So you have a surface and you have a particle. So this is the case, this is what happens when you have many lightweight particles. So if there is a lightweight particle, the direction is not fixed and it tends to move randomly in different directions. So it could move down or it could move up. We don't know which direction it may move. So randomly, it is possible that it will come and hit the surface of the filter. So this is diffusion. So these three mechanisms happen when you have a bag filter: inertial impaction, interception, and diffusion. And a parameter which is very important when you design a bag hose filter is the air to cloth ratio. Which is nothing but the amount of air flowing through each square feet of filter media per minute. And this is given in terms of Q by A. I'm sorry, this is the filtration velocity. Okay. Then coming to cleaning. So bag filters can be cleaned by shaking. So you just shake the filter, and because of inertia, the particles that are attached to the filter will come down. And then we have reverse air. So instead of the airflow being from bottom to top, here the airflow will be from top to bottom. So it will be the air will be supplied from in this direction. So whatever particles are stuck, they'll get removed and they'll fall down. And then you have the pulse jet method. So in this method, what happens is your filter is like this, and if you pass air, it will create some bubbles, and when that happens, it will create some pulses. So this pulse will travel, and when this pulse travels through the filter, whatever particles are stuck there, they'll get easily removed and they can be collected. Okay. So the next method is cyclone separator. So in a cyclone separator, the inlet is at the side, and you have a cyclone like apparatus. So this is the inlet. So what happens when particles containing gas come in? They travel through the cyclone, and because of centrifugal force, they tend to move in a vortex. So when they tend to, why this vortex happens is because centrifugal force will make them hit the surface of the container, whereas gravity will tend to make it move downwards, and therefore there will be a vortex type of motion. So when this happens, the particles which are present in the vortex when they get hit on the surface of the wall, wall of the cyclone separator, immediately they'll be out of the vortex and they'll slide down and they'll be collected at the bottom. Whereas whatever gas particles are there, once they come down, the gas particles will again have its own vortex. So the gas particles here gas particles will have its own inner vortex.
And it will move up.
And it will move up. So the gas
will be let out.
Will be let out.
There is an outlet here.
There is an outlet here. So this is the gas outlet. Since gases are lightweight, they don't stay at the bottom, and they will have its own. They'll have their own vortex motion, and they'll reach the top. Whereas the particles get acted upon by the centrifugal force, and they'll hit the walls of the container, and they'll settle down at the bottom, and they are collected here. So this is a collector. So there are two kinds of forces which are acting on the particles. Imagine this is a particle. So this force that acts towards the side is the centrifugal force, and downwards the gravitational force will be acting. And when it hits the wall of the container, initially at the inlet the particles will have some velocity, and even when it is in the vortex it will have some velocity, but as soon as it hits the wall of the container, its velocity will be equal to 0. So again, like how we saw in gravity settlers, like we had a horizontal velocity and a vertical velocity, and then we had a resultant velocity. Similarly here also, we will be having tangential velocity, which is v theta. So v theta by r is 18 mu g into vr by dp square into rho p. So here v theta is the tangential velocity, r is the radius of the particle rotation, mu g is the viscosity of gas, dp is the particle diameter, vr is the radial velocity, radial velocity is the horizontal velocity, which is acting because of the centrifugal force, and rho p, which is the density of particle. Now, if we assume that the radius of the particle is more than 0.2 times the diameter of the outlet. So here, like I said, this is the outlet, and if we assume that the outlet diameter is d0, if you assume that dp, which is the particle diameter, is more than, sorry, if the radius of the particle is more than 0.2 into du, then the minimum size of the particle that can be removed using this filter is 3.6 into ai square du into rho g into mu g divided by pi h. So this will be under square root. So here dp minimum is the minimum diameter of particles that can be removed. And ai is the cross-sectional area of the gas inlet, which is this gas inlet, right? So whatever cross-sectional area you have here, that is ai. And du is the outlet diameter. And d here is the diameter of the separator. Which is this. So this cylindrical portion, so this diameter is called d, and g is your mass flow rate of the gas.
So
when we compare different removal methods, so gravity settlers, they need large space, and advantage is that they have a low pressure drop. When we have electrostatic precipitators or ESP, their initial cost is high, but they are very efficient. And when we have fabric filters, they cannot be used in humid atmospheres. Example, when it is rainy, during monsoon season, etc. So that is there, and they are also very much prone to chemical attacks. Suppose you have a mixture of gases along with the particles, and suppose it contains acids like H2SO4 or maybe some nitric acid, etc. So these will tend to corrode the fabric and it will damage it. So these are very sensitive, and therefore this cannot be used for any when you have industries that generate acidic gases, we cannot use fabric filters for treating the effluents coming from such industries. And then when it comes to cyclone separators, they are inexpensive and easy to maintain. But one disadvantage of using a cyclone separator is that your particles should be sufficiently big. If it is going to be a small size particles, there are chances that it will just keep on rotating in this vortex, and it will just move out with the gas. It won't get removed. So that's why when you use cyclone separators, your particle size should be sufficiently high. Otherwise, the efficiency is going to be low. The removal efficiency for small size particles is low. Okay, so now we have seen various types of particulate removal methods. So then we come to gaseous and particulate removal. So the first one, when it comes to gaseous and particulate removal, so the first method is using wet scrubber. So
what happens in a wet scrubber is when you have a stream of gas containing
what happens in a wet scrubber is when you have a stream of gas containing particles.
and you
Spill some water droplets on top. What happens is the water droplet will attract the particle, and together the water droplet and the particle will settle down, and it will be collected at the bottom. So when you spray droplets of water on a stream of gas which contains particles, so the water droplet will attract the particle and it will come and settle at the bottom. So like this, when you have more particles and proportionately more water, then the mixture of particulates with water will create a substance called a slurry. So this slurry will be collecting at the bottom. So it's like a mixture of it's like how you sometimes the when it rains the road will become muddy, right? So that kind of substance is like will be produced. So it will be a slurry of particulate matter and water. So that will be collected at the bottom, and it will be removed. So the particles will be removed from the gas stream. Again, the mechanism here is just like in a fabric filter, the mechanism can be inertial impaction, interception, or diffusion. There are different types of scrubbers. So the first one is the spray scrubber. So here we have something like this. the water gets sprayed from the top. And the gas will be coming from inside, from the bottom. So the water that gets sprayed, it will just contain the particle and it will settle down. And since the gas is moving up and the particles are the gas is moving up and the water droplets are attacking the particles alone, so the gas will come out of the outlet here. The second type is a Venturi scrubber. So Venturi is something which has a broad inlet and a broad outlet, but a narrow midsection. So when some fluid passes through the Venturi, the velocity at the inlet will be low. But as soon as it reaches the midsection, because the cross-sectional area is reducing, because the cross-sectional area is reducing, so in order to maintain the same flow, the velocity will be higher. So this midsection velocity is going to be higher than the inlet velocity. And once it crosses this midsection, which is narrow, again the velocity at the outlet is also going to be lesser, because the cross-sectional area is more now. So in order to maintain the same flow rate, the velocity need not be high, the velocity will be slightly lesser. So here in a Venturi scrubber, the gas will be coming in from the top, and the liquid will be coming from here. And here the gases and the liquid will will be made to interact with each other, and then again it will be taken to a cyclone separator. So just like how particles are separated in a cyclone separator, here also there will be vortex motion, and the clean air will move to the top in a vortex, and whatever particles along with the liquid are there, they will settle at the bottom and they will form a slurry. Whatever gases are there, it will come out of the vortex. So here you have particles and some liquids are there. So when they interact, the liquid will attract the particles and it will come in here, and it will come down as a slurry, and whatever gases were there, it will just form a vortex motion and it will come out. And the reason for having a a Venturi here is because, like I said, in the midsection which is narrow, the particles, the velocity will be slightly higher. So the liquid particles and the gaseous particles, since the velocity is going to be higher, there are high chances of the particles getting collided with the liquid, and therefore there are high chances of them forming a slurry together. Okay, so now coming to removal of gaseous pollutants. So we discussed the two methods. I gave you the definition of those two methods also. So can you recall them and tell me what they are? So I was talking about some surface separation and bulk separation, right?
Ma'am, that is absorption and adsorption.
Yeah. So absorption and adsorption. So under absorption, we can have chemical absorption, physical absorption, and then physical and chemical absorption. And for adsorption, there are many methods. For example, using silica gel or activated carbon. Molecular sieve. Activated alumina. Etc. So coming to specific pollutants, for example, we have sulfur dioxide, nitrogen NOx, etc. So for removing sulfur dioxide, we can have the dry method or dry adsorption, which uses activated carbon. So we can have activated carbon, which is a highly porous material. So when we have SO2 containing gas, we can pass it through a bed of activated carbon. So these will have a lot of activated carbon will generally have many pores. So when SO2 gas is passing through it, so the pores on activated carbon will absorb the gas, because anything which is porous will have a high surface area. So this will generally make for a good contact between the gas and the particle, because the surface area is high and therefore the contact area will also be high. So the gas will get easily absorbed on the pores of the activated carbon. And then we can have wet scrubbing. Where we can use limestone. Then coming for NOx removal. So when we say
This can mean anything
NOx,
like
this can
NO
mean
or
anything
NO.
like NO or
So
NO2.
since
So
we are trying
since
to denote by the
we are
same
trying to
term,
denote
that
both
is
by the
why we
same
are
term,
saying
that is why we are
NOx,
saying NOx,
NOx.
NOx.
So X can
So
be
X can
either
be either
0
0
or
or no, so
it can be
it can
either
be either
1.
1 or 2. So the first method, I mean, the first process of removing NOx is by preventing its production. So we can control the NOx production by minimizing the residence time at peak temperature and reducing the peak temperature also. So when we talk about peak temperature, it means the temperature of combustion. When we have industrial processes where we are burning or combusting nitrogen containing waste, so there are high chances that NOx gases are produced, and that will happen when you have a peak temperature or a very high temperature. So either you can control the time at which you maintain the high temperature, or you can even reduce the temperature so that it doesn't reach the peak temperature.
The
The
second
second
is
is
reducing
reducing
the
the
oxygen
oxygen
availability.
availability. So this can be done by reducing the oxygen concentration. So there is something called low air combustion, low
Low
excess air
excess air
combustion.
combustion. So the
So the
more
more
oxygen you
oxygen you
have,
have,
the
the
more
more
chances
chances
are
are
that
that
nitrogen
nitrogen
will
will
combine
combine
with
with
the
the
oxygen
oxygen
to
to
produce
produce
NOx
NOx
gases.
gases.
So
So
in
in
order
order
to
to
avoid
avoid
this,
this,
we
we
are
are
reducing
reducing
the
the
oxygen
oxygen
supply.
supply.
So
So
this
this
can
can
be
be
done
done
by
by
recirculation.
recirculation.
So
So
sometimes
sometimes
what
what
happens
happens
is
is whatever gases that are produced during the combustion, those are called flue
gases.
gases.
So this
So
can
this
be a
can be a
mixture of
mixture of
NOx,
NOx,
SOx.
SOx,
It
it
can
can
even
even
have
have
CO2,
CO2,
CO,
CO,
etc.
etc.,
And
and a little bit of
oxygen,
oxygen,
minimal oxygen.
minimal oxygen.
So this flue
So
gas,
this flue
when we
gas,
instead
when
of
we
oxygen,
instead of
so
oxygen,
generally for
so
combustion to
generally
take
for
place, you
combustion to
need
take
some
place, you
gases,
need
you need
some
some air,
gas, you need some
you
air,
need oxygen
you
for
need
the
oxygen for the
combustion
combustion
to
to
take
take place
place
so
so
that
that the
the
material
material
gets
gets
burned.
burned.
But instead of
But
supplying
instead of
oxygen, you
supplying
supply flue
oxygen, you
gas, which
supply
has
flue
minimal
gas which has
oxygen.
minimal oxygen.
So then what
So
happens
then what
is
happens
the
is
NOx
the
production
NOx
will be
production
slightly
will be
lesser
slightly
because
lesser
NOx
because
forms
NOx
only when
forms
there
only
is
when there
excess
is
oxygen.
excess oxygen.
So when we
So
cut
when
down
we
the
cut down
oxygen
the oxygen
concentration by
concentration
introducing
by
flue
introducing
gas
flue
instead
gas
of
instead of air,
then
then there are
are low
low
chances
chances
of
of
production
production
of
of
NOx.
NOx.
And then
And
the
then
third
the
way is
third
to
way is to
modify the design
modify the design
conditions.
conditions.
So this can
So
be
this can
like you
be
can
like you
change
can change
the
the
dimensions of the
dimensions of the
reactor,
reactor, or you just you design the
design the
reactor in
reactor in
such a
such a
way
way
that
that
the
the
temperature
temperature
is
is
slightly
slightly
reduced.
reduced.
Maybe
Maybe
you can have something
something
like
like
a
a
gradient.
gradient
Instead of
heating it at the peak
uniformly
temperature.
heating it at the peak
You can
temperature, you
introduce a
can introduce a
gradient type of heating,
gradient type of
etc.
heating, etc.
So all this can
So all
be
this can
done
be
to reduce
done
the
to
NOx
reduce the
production.
NOx production.
And once
And
the
once
NOx
the
gas is
NOx
formed,
gas is formed,
for
for
treatment
treatment we can
use
use
one of the
one of the
following
following
methods.
methods. The first one is absorption.
Absorption.
So absorption, like I said, it is a bulk phenomenon. So here we'll use a lime slurry. So
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 lime
lime
slurry
slurry generally means calcium hydroxide. So this slurry will capture the NOx. It will react with the NOx, and it will produce carbon dioxide and maybe some precipitate. Sorry, nitric acid and some precipitate in the form of calcium carbonate. So this can be done, and then adsorption.
can be done using activated carbon
Using activated carbon
or silica gel. Both are good adsorbents.
or silica gel. Both are good adsorbents. And the
The third
third way
way
is
is
by
by
catalytic decomposition or catalytic reduction. So generally you have a catalyst. So it's a solid substance. So when you have NOx gas, it will tend to reduce this NOx to nitrogen and oxygen. It will tend to separate. So this catalyst will itself get oxidized, and it will make the NOx get reduced to nitrogen. So this catalytic reduction can be of two types. First one is selective. So this means that only NO can be used in this catalyst. Like I said before, NOx can be either it can be NO or NO2. But when you use a selective catalyst, then only NO can be used. But so only NO can be used, and that will get converted to nitrogen. And then there is the non-selective type. So here both NO and NO2 will get reduced to nitrogen. And then we have carbon dioxide removal. So for this we will use a method called chilled ammonia system. So here what happens is carbon dioxide will react with ammonia, chilled ammonia. And it will form ammonium carbonate or bicarbonate. And now we have covered major gas pollutants as well as particulate pollutants. So in general, when we have air purifiers at homes or offices, there are two types of air purifiers. One is the active one. So in active air purifier, it will release negative ions or anions in the air. That will make pollutants stick to surface. So can you tell me what is a
passive air
passive air
purifier?
purifier?
It will release, cations, ma'am.
No,
No,
a
a
passive
passive
air
air
purifier
purifier
is
is
something which
something
will
which will
not
not
release any
release any
ions.
ions. So it's just
It's a basic air
it's a
purifier
basic air
where
purifier
it'll use
where
some kind
it
of a
will use some
vacuum
kind of a
to
vacuum
suck
to
in the air,
suck in the
and
air, and as the air with
air moves through
air moves
the
through
filter,
the filter,
the filter
the
will
filter
remove
will
all
remove
the
all the
pollutants.
pollutants. So there is vacuum, and here the anions will get released. So since it is releasing some ions to the atmosphere to remove the pollutants, it is called active. And in case of passive, since there is no such release, instead it's like a filter through which the air is passing through, and as it passes through, it gets the particles will get filtered. So that is the difference between the two. So a passive filter is more efficient when compared to the active filter. Can you tell me why?
So when you have
Okay.
an active
So when
filter,
you have an active filter,
it is generally releasing
it is
some
generally releasing some
anions, right? Which
anions,
are
right?
negatively charged.
Which are negatively charged.
Now, if
Now,
your
if your
pollutant is
pollutant
positively
is
charged,
positively
then
charged,
maybe this will
then
have some
maybe this
effect.
will have some effect.
And also,
And also,
there should be
there
a
should
higher
be a higher
concentration of your
concentration of your
pollutant near
pollutant near
the
the
filter
filter
for
for
it
it
to
to effectively
neutralize
neutralize
the
the
pollutant
pollutant
using
using
anions.
anions.
Whereas in a passive filter,
Whereas in a passive filter,
we use
we
vacuum
use
to
vacuum
attract
to
air
attract air
inside.
inside.
So if
So
the
if the
air,
even if it
contains a little
contains
bit
a
of
little bit
low
of low
concentration of
concentration of
pollutant,
pollutant,
even that
even
will
that
get
will get
pulled into
pulled
the
into the
filter,
filter,
and
and
that will
that
be
will be
removed.
removed.
So
So
active filters are ineffective when you
active
have low
filters are
concentration of
ineffective when
pollutants,
you have
whereas
low
passive filters
concentration
are
of
useful even
pollutants,
at low
whereas passive
concentration and
filters are
high
useful even
concentration
at low
both.
concentration as
So
well
that
as
is
high
why they are more
concentration both.
efficient.
So that is why they
And
are
an
more efficient.
example of the active
And
filter,
an example of
passive
the
filter
active
is
filter,
HEPA,
passive filter is HEPA,
or high efficiency
or
particulate air.
high efficiency particulate air. Okay.
So with
So with
this, we
this,
will
we've
come to
come to
the
the
end
end
of
of
this
this
session.
session. So then we'll move on to some question and
Answers.
answers.
So before that, if you have any
So before
doubts,
that, if
just
you
let me
have
know.
any doubts, just let me know.
Yes, ma'am.
Yeah.
Yeah.
Ma'am, it's apart from the subject, ma'am. There is two sessions, ma'am. Is that two sessions are same, ma'am?
Yeah, it's
Yeah,
the
yeah, it's
same.
the same.
Okay, ma'am.
So
You can
attend.
attend.
There are
Actually, there
three
are three
sessions
sessions
happening.
happening.
One is
One
on
Okay,
is on
ma'am.
Saturdays,
Saturdays,
and
and
two of
two of
them are
them are
happening
happening
on
on
Tuesdays.
Tuesdays.
Okay, ma'am. Okay, ma'am.
Yeah.
Yeah,
Thank you, ma'am.
yeah. So all of them are parallel.
Yes, ma'am.
Yeah. Okay, coming to the questions, MCQs. So first question is, what is the typical air to cloth ratio for filter bags, for bag filters?
Option B, ma'am.
Yeah, that's right. So air to cloth ratio is given by the formula V equals Q by A. So Q is the flow rate of air, and A is the cross-sectional area. So that should be in the ratio of 1.5 to 3.5 for bag filters typically. Next question is which process is the most efficient for removing particulate matter with size less than 1 micron? I'm sorry, it's displaced as 11, but it's actually 1. So which process is the most efficient for removing particulate matter with size less than 1 micron?
Cyclone separator.
Actually, cyclone separator is an option which can be used for removing big size particles. Like how we discussed in a cyclone separator, if you have small size particles, there are chances that it will tend to move up along with the air. Because here the condition is that the centrifugal force and gravitational force both are acting. So the centrifugal force depends on the mass of the particle. If the mass of the particle is high, then only it will go and hit the wall. Otherwise, if the mass of the particle is less, then there are high chances that it will just keep floating here and it will go up along with the air. So cyclone separator is incorrect. Any other answers? Okay, the correct answer is fabric filter. So a fabric filter, generally we use cotton or a nylon, which will have very small pore size. And generally the efficiency is more than 99% for particles which are greater than 0.01 micron. Now, since the question is which process is effective for removing particles of less than 1 micron in size, we can say that fabric filter is useful because the other equipments, they are not very effective at removing particles which are less than 1 micron in size. Like we discussed for gravity settler, it should be more than 50 microns. Okay. Next question is, which of the following adsorbents can be used for removing CO2? Any answers?
Activated carbon.
Yeah, that's right. So activated carbon can be used for removing methane and CO2. Silica gel can be used for removing ethane and other heavy hydrocarbons. Whereas activated alumina can be used for removing water. And molecular C5A can be used for removing methane, carbon monoxide, nitrogen, and moisture. Okay. Which of the following methods use inertial impaction for removing particles in air?
Ma'am, both fabric filters and cyclones will come now, ma'am.
Yeah, fabric filters, but are you sure cyclones?
No, ma'am, no, ma'am, no, ma'am.
Yeah, since cyclones are like it's not based on inertial impaction. I mean, there are two types of forces acting. One is the centrifugal force, and one is the gravitational force. But when it comes to fabric filters, so the particles will come from inside and they'll just get impacted because of inertia. Because they cannot really, heavy particles cannot flow to the top and move out because their inertia will be there, and the heavier the particle, the more will be the inertial force. So that is why it will get trapped inside. So inertial impaction will be acting here. Okay. Next question. Which of the following methods is suitable for removing
Sticky,
flammable or highly corrosive particulate matter?
Ma'am, is that Venturi scrubber?
Yeah. Because we cannot have, since electrostatic precipitators uses current, we cannot have anything which contains a lot of moisture or corrosive. And bag filters, they are highly prone to chemical attacks. And if we use sticky substance in adsorption, then the pores will be blocked. When you use activated carbon, etc., so which is highly porous, so the pores will be blocked when you use something when you pass a gas which is very sticky, which contains sticky substances. Then the pores of the carbon will be blocked. So you have some long pores. So if there is a sticky substance, then it will just block the entrance to the pore. So when you have some pollutant which actually needs to be removed, it cannot enter it. So that's why all the other options are incorrect. So when you have something which is corrosive and sticky, it's better to use a Venturi scrubber to remove it. Okay. So with this, we have come to the end of this session. If you have any questions, just let me know.
Ma'am,
Yeah.
I have applied for the exam, ma'am. Is it enough of learning these lectures and
Yeah, like it's enough if you practice the assignment questions and watch the lecture videos, attend the live sessions. I think it will be more than enough.
Okay, ma'am. Thank you.
Any other questions on week 5 lectures? If there are no other questions, then we'll end this session. Thank you all for joining.